Hello, welcome to ATTC 3260. I wanted to give a brief overview of the course, tell you a little bit about myself, and hopefully we have a good time this semester. So this is our Canvas course. We'll go over some of that content here in a second. This is me right here. It was 15 years ago, so I look about 50 years older than that now. But I've been teaching at Weber State for about 15 years. I've really enjoyed it. I've primarily been teaching electrical and electronic systems. I have a degree in automotive technology from Weber State. I also have a degree in computer science, so I do a lot of programming as well. And then I have and that's from Weber State as well. And then I have a master's degree in something called instructional technology and learning sciences. It's kind of a fancy way of saying that, or a way to make courses hopefully helpful to students. Prior to working here at Weber, I worked for the Toyota Motor Sales. I did some work in their electrical electronics division. When they were in California, they're in Toyota, they were in Torrance, California. Now they are in Plano, Texas. So I helped technicians figure out, challenging electrical problems, and did some really cool work on some of their current gen vehicles. At the time. Now they're old vehicles. Before that, I worked as a technician at a Chrysler dealership. I primarily worked on the Dodge diesel Cummins vehicles. At the time, they weren't called Ram. But we were a pretty small dealership. I think there was 4 technicians, and so we kind of just got a chance to work on everything. Electrical's always been kind of the one that I've been most interested in. I was in the Air Force. Joined the Air Force in 2001, right before September 11th, and I got a chance to work on this aircraft. It's called the KC-135. They're starting to retire this. You'll still see some of these flying. I was stationed in Kansas at McConnell Air Force Base. I spent a lot of time in the Middle East helping to service the aircraft there. So this aircraft does in-flight refueling. So you can see kind of on this left picture, they have a boom that sticks out the back, and it can help fuel other aircraft. They were built in the 60s, and we did a lot to help maintain them. It was interesting to work on such an old platform with such modern equipment on them. So kind of interesting. I really enjoyed my time as an aircraft mechanic. And when I got out, I considered working on civilian aircraft, but they kind of have a strange structure of seniority before you have to get to work day shifts and stuff, and so I switched over to working on vehicles instead. Kind of my current area of interest is I also teach a class for computer science in their master's degree program. And it's about autonomous vehicles, so it kind of ties my automotive background with my computer science background. So this little thing looks like a Roomba. It's called a Turtlebot, and it's on the same platform as a Roomba. I think iCreate makes them, and you might recognize this. This is a LiDAR here on the top. Well, a simulated LiDAR. It's actually a 3D scanner. Shoots out little lasers and measures distances, but they have it on a rotating platform, so it has a 360 picture. It also has this stereo camera here on the top. This is similar to what you would find on like the iSight and Subaru, as well as Tesla has this. Most vehicles that have any kind of lane keep assist are going to utilize some type of camera system like this. This is just a little fancier one. It has this little platform. The Turtlebots that we have on campus, we've removed those components from, and we teach computer science students how to program these. Hopefully be able to bring some of this stuff into the automotive platform or automotive department as well. We also have a Kia Niro that we have on campus. We have a system on there that allows us to drive it with a remote control, like an Xbox controller. It's pretty scary to drive it like that. It was interesting to be able to break into essentially the CAN bus and communicate to the steering system and control the vehicle, and it was actually a fairly easy process, so kind of crazy there. And then I do stuff we have a Tesla Model X as well. We had a Model S. We still have it. We don't drive it on the road very much anymore, but we have a Model X and we do stuff like that. I personally own a Tesla Model 3 that has full self-driving capabilities and get to drive it up to school every day. I live out in Tooele, so if you're not from Utah, you might not know where that is, but it's kind of out by where the airport is. It's about 45 miles from campus, so I get quite a bit of time on the road with that vehicle. Kind of the things I do on my own that are interesting. I do stuff obviously with computers, but I really enjoy 3D printing. I picked this up maybe 7 years ago. Well, no, it's probably a little more than that, maybe 10 years ago. Weaver State had a 3D printer, and I started learning some CAD design work and started printing on their system. I think they had a Stratasys, which is one of the kind of original 3D printers, really expensive machine. They now have hobby level machines that can pretty much do everything, and at Weaver State and at my house. Weaver State owns several of these. I own personally several of these now, but this is a company, and I'm not sponsored by them or anything. They're just, if you're interested in 3D printing, you're probably familiar with this company. If you wanted to get into 3D printing, there's this system right here. This is what I use. You can do 4 different colors. You can actually add additional ones of these units. This is called the AMS, Advanced Material System. I don't know what it stands for. But anyway, it allows you to print in multiple colors. So essentially, a 3D printer, what it does, it melts plastic into a really small diameter. Most of the time I'm doing about 0.4 millimeters, but you can get down to 0.2 millimeters and smaller. And it melts out a layer down on this build plate, and then it builds up a model. And so for a long time I was just kind of printing, tool organization stuff and things like that. But as I got better and better at it, I started thinking of practical applications for it. So recently, I, along with Brandon Stevenson, he's another faculty member here, him and I helped develop this system. So this is called the MMTS, Magnetic Matte Electronic Training System. So it's kind of a complicated name, but essentially what it is these are nodes. So this is 3D printed, this little wire node right here. And then you'll see these kind of jacks that come out of them. And then inside of this node, there's a printed circuit board, a PCB. Printed circuit board, we're going to get into a little bit in this class, but a printed circuit board's purpose is to be able to create an electrical connection between points and have components on them without having like a physical wire like this. So nearly every device that you use that has an electrical circuit in it is going to have some form of a printed circuit board. And so we'll look at those printed circuit boards. I'll share with you some places that I get I design them, but I have places that they can be manufactured in China. They're relatively inexpensive. You can make some pretty neat projects. So this specific system, its purpose is to teach students basic electrical diagnostics. So they'll take this, you can set a fault with the printed circuit board in the back. And you set a fault and say, hey, I want this wire to have high resistance or an open. I've got switches. This is actually a computer, and we'll look a little bit at that during our class, and batteries and so on. And so this is really a fault setting test equipment. So I set a fault, and a student has to figure out where the fault is in the circuit. So it was really fun to be able to take time to be able to create this. It was interesting to learn about printed circuit boards and the manufacturing of those and everything. So that's been kind of a fun project I've been working on lately. So I developed them for my own classes, and then we started we talked to Weber, and we're going to license this out to a company that Brandon and I started together, SBC Training. So Scott and Brandon Company. We're not super creative in names, but there were people that wanted to utilize this system on their own, and so we'll be selling this product. So it's been kind of cool to develop that and figure that out. So that's just a little bit of background information on me. Show you kind of the things that I'm interested in. I'm mostly interested in the subject, this specific subject, and I do stuff with it in my spare time as well, not just in class. So this class is typically taught face-to-face in the lab. A couple years ago, we decided to start thinking about the option for students to be able to do this online, and so It's a little more challenging because you're going to have actual components that you'll be doing things with, and we'll get into that here in a second. But it's going to there may be some road bumps as we're moving along, and so I ask for your patience as we try to get things figured out. I want to make sure that you have as good of an experience as you would have had in the lab without just watching a bunch of videos and completing online work. I want you to be able to do hands-on work. Okay, so first thing up here is this course business. So this is just stuff I keep here at the top in case you have to communicate with me. So let's say, hey, I need help with whatever. This is my official Zoom room. So this information right here, this is the meeting ID and everything. Now, you could actually just hit join Zoom meeting and it'll notify me that you're trying to meet with me, but that could take a while. So what would be better is send me a text or an email. This is my email address. This is my cell phone. So you can send me a text and say, hey, can't figure this out. You got some time to meet, and I'll try my best to be able to accommodate you. I'm going to need a little bit of notice. If you just send a text message, if you send either a text message or email, I usually within a day can probably respond back to you. If you want to meet in a Zoom meeting, that I might need, at least one more day of notice to be able to do that. So unfortunately, I know how it is. You wait until the very last minute of trying to complete an assignment, and then you're like, oh, I don't understand this part. That's going to be pretty challenging for me to meet with you, but if we meet ahead of time, that hopefully you'll be able to get that. I also do this in my computer science classes. I don't know if anybody prefers Discord. Discord is just a communication thing. I think they started it for gaming, but a lot of my computer science students prefer Discord. This is simply just like not a message board, but a way to communicate in the class. You can do it privately so that no one else sees it, or if you wanted to ask a question that everyone else does, that's a great way to be able to contact me. Now, email through Canvas, that's the least preferred method. It'll take me a while to be able to respond to that. I have to log into Canvas, and it's a little bit more complicated, and so these are the kind of the first things that you should be considering. A text message, I'm pretty good about answering those. If you do send me a text, just include your name and the class you're in. Otherwise, I get to give my number out to a significant number of students, and so I want them to be able to know, or I don't know who they are. And so when you text me, say, hey, this is Jimmy from ATTC 3260 or whatever. Okay, so back here, let's take a look at the course syllabus. So here's the syllabus. Once again, that's me. I don't necessarily have specific office hours. If people are like, hey, I'd love to meet on Tuesday mornings, and we have several people that want to do that, I can definitely do that. But since I give you my cell phone number, you really can contact me anytime and we can set something up, rather than me just sitting around waiting for students to be able to respond. So this class is all the way online. I do have a lab, so my lab is in the Computer Automotive Engineering building, CAE 128. If you take the electrical courses in the associate's degree, that's just the electronics lab. If you want to, you absolutely can come to campus and just work on this class in that lab. So we have a class there on Monday mornings, and there usually isn't another class going on. So if you wanted to come in kind of during business hours, I could definitely accommodate you. And I'm usually there Monday, Tuesday, Thursdays, and off and on Wednesdays and Fridays I'll be there, but I usually spend that time out visiting other schools and stuff. So if you wanted to come to campus with questions, that'd be fine. If you want to work on your labs in the lab, that'd be fine also. I built this kit that I'm going to show you here in a minute, with the intention that you could do this all on your own at your house and you have all the equipment that you need, but just keep that in mind. That's definitely an option if you would like it. This is just the standard syllabus information about being professional and stuff. We won't be working in the shop, so you don't have to worry about shop safety stuff. Obviously don't poke your eye out. You probably should wear safety glasses when doing anything with tools. I have the standard grading numbers and percentages, so you can just look at it there. So this is kind of how your grade will break down. 25% of your grade will be based on a final project. So we've got these little cars that we are going to be programming to drive themselves, and we'll be using a platform called Raspberry Pi that will be utilizing, and that'll be all part of your final project. It's totally fine if you come into this with zero background in there. We're going to be covering all of that. Most of our lab activities will revolve around this computer. It's the same kind of computer that would have the same processing capabilities and speeds as probably a body control module in a vehicle, and maybe even a powertrain control module. It will be it's actually probably a little bit more sophisticated than those, but it gives us kind of that understanding of how a computer-controlled car kind of operates and the things that it can do. These lab activities, they're intended to be experiments that you'll be performing with your Raspberry Pi. So you'll be hooking up input devices, looking at the information that it provides to the computer, and then controlling output devices. So just like a computer on a vehicle, we'll be working through lab activities to kind of look at that type of stuff. And then assessment quizzes. These are just quizzes that ensure that you're kind of understanding the content as we're moving forward. They should be pretty straightforward. Typically in this class, students either do very well or they don't pass the class. So it's usually the reasons they don't pass the class is they just don't spend the time doing the work. There's nothing that's extremely challenging here. You just have to spend the time, putting in the effort to get the class complete. Okay. Let me know if you need any kind of accommodations. Online's a little different, but we can do any kind of accommodations as needed. Okay. All right, this is the thing that I need you to do this week. So you will, by September 1st, I need you to fill this information out. So I have a kit. It's probably going to be about 35 pounds. It comes in a case, and it contains an oscilloscope, the Raspberry Pi, several components that will be connecting to the Raspberry Pi, your car that you'll be programming. All of that comes together in one. As I mentioned before, it's intended to be a device that you can have everything that you need to do experiments on your own. I need to send those. I need you to get that kit. So if you live within 50 miles of campus, I need you to come and pick up the kit. And so you're gonna indicate this right here. Everyone else, I'm gonna ship the kit out to. So it's gonna take us about probably 2 weeks. So the second week of September is probably when everyone's going to have all their kits, and then you can start doing that. So if you live outside 50 miles, then you have the option. You still could drive to campus if you wanted to pick it up, or I can mail it to you. So I'll mail it to your address, and then when the course is over, those of you that picked it up, you'll come drop off the kit. We'll make sure all the components are in there. And those of you that we mailed it to will be able to send you information so that you can mail it back. Okay, so I need you to fill this out before this September 1st. The rest of the course, so right now this is the only information that I have published. The rest of the course, we had a kind of a last minute change on the type of Raspberry Pi that we're going to utilize. And so I've got to do some updates to these labs. These will be published as we get to the week. So you'll have some time to be able to work ahead if you want. You can expect somewhere around an hour's worth of content that you'll be reading or watching, and then somewhere around that same amount of time to perform your experiments per week. So it's not extremely labor intensive, but you're going to need to do a little bit each week as you progress through the course. So I'll start publishing these once people start getting their kits, and we can proceed. So the only thing you really need to do the first week is, if you want to sign up for the Discord server, do that here, read through the syllabus if you want to do that again, and then identify your pickup options for the kit. Okay, I hope that you enjoy this class. This is probably one of my my favorite classes. The content I think is really interesting, and hopefully you'll enjoy it, and reach out to me if you have any questions. All right, good luck.